Hey everybody, and welcome back to Human Resource Machine. There we go. Sometimes it doesn't like to get past that screen. So, we were working on the coordinator, trying to optimize it. So we're just trying to figure it out. That's right, I hadn't even solved it yet. No, never mind, I have. I've totally solved it. It's just, I solved it in a way that they didn't want me to, I guess. So I've been coding all weekend. Just an event for the office. We're working on some personal projects basically all weekend. A lot of fun, but I'm gonna see. I don't know if it will have burned me out or if I'm gonna be more focused. So I haven't even thought about this problem in the slightest since we last looked at it. So hopefully we'll figure this out. So we need to take the number from the inbox and address of a tile on the floor, send the outbox the coordinates of that tile, column first, row second. So remainder and then divisor. So that's how I did it the first time, was using division. They've got a 0 and a 4 though on the ground to get started. So it's really rather odd. I'm not entirely sure why there's a 4 there. It's just odd. Because I can... Just trying to think here. I knew this was going to happen for this one, because I've got to look at it and try and figure out the right way. Because the way we did it first, if you haven't watched the previous episode, the way I did it before is I took the number and then I basically divided it by 4, which makes sense for having a 4 there, until it was a negative number. We used the subtraction method to divide. See, this is what you perfectly need for division. I'm really wondering if I just messed up the division code. Because this is the denominator. This is just 0. So this... See, the thing is, I don't know if they put this here as an example, and we don't need this many memory spaces, which is completely reasonable to me. And this is... Shoot, I forget if quotient's the right term for the answer. Because basically, we inboxed... copied it to the number, which made sense, and then we copied from 0, we copied it to the quotient, and that was our initial conditions. Because after that we basically went... well, none of them's... We could have a 0 technically, but we don't right now, so I'm going to ignore that case. We did copy from denominator. I need to double check. I always forget what subtraction does. Whoopsie. That's a copy from 0. Okay, that's not right. Right, so we'll copy from 0 first. copy from 0, copy to quotient, inbox, copy to number, subtract the denominator. So then, if it was negative, we did something else. If it wasn't, we bumped the quotient. No, we copied it to number. We bumped the quotient. Yeah, and we kept doing that. And then oh yeah, I'm sorry. All of it's coming back to me. Seriously, all of it's coming back to me. I prefer this one. And then if it was negative, what was it that we needed to do first? Column first. So the remainder. So if it was negative, we copied from there and outboxed. We copied from there, outboxed. This looks familiar. So the reason why I don't think this is the correct answer for their optimization is not because I think this is inefficient. I think this is probably one of the more intelligent ways of doing it. At least sensible ways of doing it. Perhaps not extensible, but we just learned the get thing here. So we could spend a bunch of time populating this with something, but we don't have any way of getting this, so it doesn't really matter is the problem. I mean, here we don't have 14 or anything like that. Because we could fill this in with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. No, we can't because we don't have the ability to address via these. If we had the ability to address via these, then yeah, but those are just there for reference. This entire grid has to be there for just reference. Well, let's see if this works. It's negative. So we copy from number, copy from quotient. Yeah, this should work just fine. So, I forget how close we were on optimizations. Looks like this just makes sense to me. 1 too many. 6 too many. Okay. Yeah, this is the right way. We just have to find the inefficiencies. I think that's it. I think it's just finding inefficiencies. I feel like I was off by more last time, because it made me feel like I was doing it the wrong way. I was off by enough, but if it's one instruction being run 6 times, then that's it. So it's something in here. Yeah, here's the problem. No, because we can't bump 0. So here's the thing. We have a slight problem in this loop, because this copy to, like, we could do really good things here if we didn't have to bump the quotient. If we could always bump the quotient. But the problem is we can't do that Sorry, I'm thinking to myself. The reason why we can't do that is because, basically, we're constantly holding the number that we want, but this bumping of the quotient, the fact that it makes us take from quotient makes us have to do this extra, which is really bad. Now, I don't think there's a way for us to organize this in such a way that we either have fall through. But that's like one of the few ways we could actually do this. I'm remembering the problems now. All the problems. So we inbox, that makes sense. I mean, if we do this. See, the problem is we double up here. This doesn't actually change anything. Because we need to have this copied a number, because we need to preserve the subtraction that we just did. Then we have to bump the quotient, and then we have to get back to this. This doesn't actually change anything. We should still be off by 6 and 1. We definitely didn't change the number of instructions, obviously. Okay, but we did reduce our number of instructions by 2. Which kind of matters. It could matter, I guess. Every little efficiency usually helps. Alright, if we didn't have to do this every time. Is there any way that we can make this easier? We have to do this. Because when we are holding here, we're holding a number. Now, I could make this slightly sillier and add the denominator back, but it doesn't actually change anything in terms of speed. So... I'm thinking of ways that I'm trying to think of ways to remove instructions first, because I could add some extra instructions to make this, to give us less instructions, like executions for the speed, but at the same time, that's not exactly where I want to go right away, because then you have to prune that all back down, and I think this is the harder task, is removing the one instruction that's bad. This jump, like, the thing is, this jump seems really out of place. If that makes any sense. Like, these are really close, and that says something about being able to do things. The problem is our way out is if it's negative. We don't have any way, do we have any way of switching that up? Or is there just actually a faster way to do this? I don't think there is. If we had extra space, I would think there was a different way, but it's like with 2, 3, 6, and 10, I can do this. Like, with relative ease, doing some shenanigans with numbering. But the problem is, that doesn't, like, we had one that had a 14 in it. which means I have one memory space that I'd be able to use in the interim, and that doesn't work. Like, there could be something really interesting with incrementing 2 zeros, right? Incrementing 2 zeros and running through here, checking 0, 1, checking 0, 2, checking 0, 3. But unfortunately, that doesn't exist. Like, we can't do that because we don't have the memory space to do it, which really sucks. Yeah. Like, I can think of some like clever things to do. Like, we can put zeros here, ones here, twos here, threes here. Actually, no, we'd want to do it the opposite. We want to do zeros, ones, twos, and threes. And then, you know, over here, you drop down your number, and then you go ahead and you go to the number, and that's your column, because we just did that, right? Put zeros, ones, twos, and threes. So that's your column. Cool. Then you pull that number, you pull that column number, you set it somewhere else, and you decrement it while subtracting the denominator, and which is 4. And then so if I had 6, right? I've got 2. Actually, no, that doesn't work. Okay, you could do some silly. Yeah, okay. You could do some interesting things. Because you could say, hey, do this subtraction. You subtract your column from your number, and you get the duplicate of 4 that is your row. So you'd get 4 here, you'd get 2 here, yeah, you'd get 8 here. And then you could subtract 4s until you had 0, and incrementing this, use this division. But then guess what? We're using the division, which is immediately less efficient, because with this division we're getting exactly what we need. We're just jumping if negative, which means we're maybe running through this step one more time. So that way might be more efficient speed-wise. It might be. But the real problem is we don't have the memory addresses to do it, because we need one memory address to hold this 4. We arguably need one memory address to hold the 0. Well, yes, we need one memory address to hold the 0. We do need one memory address for the quotient, because the quotient, because we need to subtract, we do the division by 4. And we need one memory address for the number itself. So we need 4 memory addresses, which basically pulls out these 4, which means we're only looking at this. But for this set of numbers, that works. But we've had a set that has 14 in it, which suddenly we can't do because we can't put 0s, 1s, 2s, and 3s down through everything and still recover this, because we don't have the memory to do that. So that brings us back to this, of course. I can't, all of this is necessary. 100% necessary. Now, if I want speed, I could build this loop, do this, build that loop again, and then have the jump come back to here. That would actually make things go a little bit faster. It would remove like a couple jump steps. Actually, sorry, we don't need to check if it's negative right there. I really wish we just had a jump if positive. I really wish that was a thing. That would solve all of these optimization problems. Okay, let's approach this the other way. Instead of subtracting from the denominator, let's add. Can we do that? Is that reasonable? Why not? What do we want to call this? Let's call this the sum. Because I'm still jumping if negative. No, I'm not. No, I'm not. Okay, so maybe this might not work. This isn't gonna work. Yeah, this isn't gonna work. I'm still gonna do it though, because I want to see. All right. So, the way this is gonna work is we end up with a sum of 0 here. Do we ever want that? Yeah, we do. We need it to start at 0. So we've got our number here. We've got 0, 0, and 0. So we copy from denominator. We add it to sum. We store it in sum. And then we subtract the number. If it's negative, we keep going. Crap. We don't want 0. Oh no, that's okay. We can make this work. We're going to bump the quotient. Yes, we're going to bump the quotient. So the way this works, we bump the quotient, so that's the loop that we're on. When we copy from the denominator, we add it to the sum, then we copy it to the sum. We then subtract the number. Yes. Okay. So we end up so with 2, we'd end up with 2 and 4. That's what they would be. And it would be positive. So we'd know that we had gone too far, and this would be 1. So we don't copy from quotient. We bump quotient down. That is basically like copying from, but we can do that quick adjust that we know is going to be positive. And actually, this might have solved the problem, but for the previous rendition, we'll get there. Actually, it totally does. Damn it. Anyway, I'm going to keep on with this because this is where I started. Mostly because it might not have solved the problem. I'm hoping in the back of my head that it solved the problem. So we bumped the quotient. So now we've got 4 and 2. So we know... we subtract the number. So we'd end up with positive. And that positive, is that our row? I think that's our row. It works for 2. Okay, well, okay, so it works for 6 too, because they're in the same. So 3 is 1. So it's actually not our row. But I'm still gonna check. I'm still gonna check. It's not gonna work. Because that doesn't give us our row. If we could... This is really bad. Technically that works. I mean, we're pretty close in terms of instructions, I think. So let's watch this maybe work. I want you to be faster. So this is our initial conditions, right? We bump the quotient, because we're going to presume that it's right. We copy denominator, we add to the sum, we store the sum. So we subtract the number. We are not negative. So, we copy from our denominator, we subtract our sum. Shoot, that's not right. We need to copy that to sum. We need to subtract this. The problem is we basically need to take what that is. It's bad. It's bad. Just, I'll tell you now, it's bad, but this will work. Okay, we start with 10. So this will be a good example. So it's negative, so we keep going. We bump the quotient. We add that. Still negative. We have 12. Positive. So you'll notice that 10 and 2. 2 just happens to work because it's the middle of 4. To make this look like we don't have to do this, we'll have to wait until 11 to actually see it not work, or to see an example of it not working. So we take 2, subtract that, and we outbox it. We then bump the quotient down because we have an initial bump here that we don't need. Cool. 2 and 2 is 10. So 2 is going to work just the same. Works just fine. Okay, so 11 is going to be our odd one out. So we bump the quotient. 4. Cool. This works just like we expect until we get a positive number. So we get 1. 1, 3. It's basically the sum of this and your number get you the denominator, which is why we copy that to sum, we pick that up, we subtract that, now box it. As you can see, this works. Oh! What went wrong here? Okay, we were at negative, so then we bumped the quotient, which was accurate. Right. This doesn't work when it divides exactly. Oh my god. So, yeah, this will work if we do this. This is terrible. Darn it. So the solution I thought might be clever ended up being absolutely horrible. That's really unfortunate. I mean, it worked, but it's terrible. It's so bad. It's so bad. It's so bad. Okay, I really wish there was... Oh, there is an undo. I wish it didn't bounce like this. Okay, so, how do we solve our problem? I believe the answer is here. Alright, so first off, oopsie. Alright. So we did this. Sorry. We copy from 0, we copy the quotient. We inbox, we copy its number. That's our initial conditions. We then have number, so we don't need to copy from it. Except we kind of do. Darn, I thought what I was doing before would solve the problem. I don't think it will, though. So we need to copy. We want to bump our quotient here, just from the get-go. it is going to mean that our quotient is higher, but that's when we bump quotient. And problem solved. This is to copy from. We offset our initial and our copy from. But what this saves us is we copy from the number, we subtract the denominator. If it's negative, go. Otherwise, we copy it to the number. It doesn't save us that. Darn it. Wait, we're at 15. Maybe this worked. I don't know if I'm missing something. I feel like I am. Doing a whole bunch of undos makes me a little unsure of the state of this program. So we're going to watch it. So we bump our quotient. We copy from our number. Subtract the denominator. It is negative. So we copy from the number. So that's our column. Bump down the quotient. So it worked with 3. Now we're going to try 14, which is going to do more. So bump up our quotient. Copy to the number. Get our negative number. Okay, this should work. Oh, it is 14 or fewer. Crap. And darn it, we're at more already. Shoot! I thought we were close. So these 4 are basically required. Sorry, these 5 are basically required. We can't simplify that. I mean, we can change them. Obviously, we changed this here. No, because we need... Well, we can technically do that there. This doesn't reduce our numbers, though. Also, we wouldn't have to bump down the quotient there if we do it this way. See, this is a jump if positive, and it pisses me off that we don't have that. Like, it actually is really annoying me right now. That's why I tried to switch to the positive adding, because it gave us that jump if negative loop. But that still didn't work because of an equal division problem. Goody. This is the right way to do it, it's just there's an efficiency issue here that I don't... This gives us more speed. Nope. What was that? What did I even do wrong there? Can we stick to that default, please? Oh. Yeah, we're back to this. I don't think I've changed anything. I think this is just something that we've already been at. This is the number I'm interested in. Yeah, okay. So that's as good as we've ever done before. This is part, like, there's one thing missing. There's one thing missing, and I'm gonna have spent 40 minutes now, at least, not finding that one thing. And it's gotta be right in front of me. Is it this? Is this it? I need to double check this. I didn't actually think about what's going on here. I was looking at collapsing steps, so I don't actually know if this works. Be inbox. So we copied a number. We bumped the quotient. I'm gonna have to bump down the quotient here. We copy from a number, we subtract denominator. It is not negative. What did we even start with? 7. Yeah, okay. So once again here, instead of copying from quotient, we bump down quotient, because we know that we're adding 1 always, even when we shouldn't. And then it works, and I hate myself because it took me this long to figure this out. It's always this absorption into the loop of stuff that you don't... You basically rotate the loop into the right spot. We got the size challenge. Yay! Do we get the speed challenge too? No. Okay, we actually went slower. Okay, but I think the size challenge is the hard one. I think the size challenge is the hard one. Personally. Because the speed... I mean, the speed one has its challenges, but it has easier fixes that involve writing a bunch of extra code, which is super annoying. But technically works, so, you know, whatever. So what we were doing... Basically, we want this jump, if negative, as early as we can. Because that'll pull out the most. So I think this will work, but obviously we've gone up to 15. This is why, yeah. Alright, so I want to double check that this works. Whoopsie. Was not paying attention. Why am I trying to optimize this again? I really should just hit undo a bunch. Okay, this is what got me 80, right? Yes. Alright. That's what I wanted to start with, because this is the lowest that we've ever gotten. So there are some options that immediately present themselves to me. The first one is being terrible and basically duplicating the loop. It saves us 3 instructions, I think. Yeah, I know. It's terrible, and I hate doing this, but I'm gonna do it. Yeah, I'm gonna do it. But what are you doing and why? Yeah, I know. Well, here, let's get rid of this. It's you basically run through one iteration of the loop to begin with, and then you jump into the other iteration, which is terrible, but works. It prevents jumps, basically. Like, if I wanted to... Oh, Jesus, I could do this in a terrible... I could do this in a worse way. We know our problem space is less than 16, so we could just run this loop at most 4 times. And I wouldn't have to do this jump. Oh my god, that's so terrible. And I'm gonna do it too. I am a terrible person. I am a terrible person. Oh my gosh, this is terrible. This is absolutely terrible. I hate everything about what I am doing right now. Why? Why am I doing this? Like, I'm actively not thinking about what I'm doing right now. It's so bad. Don't ever do this. Don't ever do this. I am hating everything that I'm doing about, like, I hate all of this right now. This is terrible, and I should feel bad. I'm gonna make sure it works. Okay, so 8. We're gonna go through the loop twice. It's not negative. It's not negative. It's negative. Oh, whoopsie, I took out the jump statement. So yeah, that worked. Oh god. This is what happens when you don't have to... When the jump counts as a statement, this is the bad code you end up with. I'm not kidding about that. This is the bad code you end up when you're counting jumps, or when you don't give me a jump if positive. If I had a jump if positive, I could have done this so much nicer. Oh my god. Okay. Well, we did it! Yay! The 2 lights came on. Okay, that's gonna be it for this episode because I hate myself right now. I hate myself right now. That code was terrible. But if you know the limitation of how much your loop is gonna be run, you can save yourself the time from having to jump instructions. I don't disagree with them counting jumps as, or checking for jumps as, for the speed challenge. I don't disagree with them for doing that. But because they are doing that, it causes bad code, and they don't have a jump if positive. They make stuff like that happen. Now, granted, if there was a jump if positive, the optimal target number might have been lower, which would have meant I still would have had to do some silly things. But, oh my gosh. That was just, ew. Everything about that was terrible. I feel so dirty writing that code. Anyway. That's not the only time that's happened. It won't be the first, and it won't be the last. Or it wasn't the first, and it won't be the last. Especially the fact that we still have Oh no. I didn't even look at the names of these. Alphabetizer sounds interesting. Digit exploder also sounds pretty interesting. I imagine that's taking like a multi-digit number and putting each one in the outbox one by one. Like hundreds, ones, tens, or something like that. Anyway, and then prime factory sounds like we're messing with prime numbers. No idea about sorting for, obviously sorting stuff. Anyway, I have a feeling that each of these is going to take about an episode to optimize, and then this might be the last episode, but I'm not sure about that, so I don't know. I mean, this one took an entire episode, and we still did a bunch of it on the last episode too, so I don't really know what to expect, but I'm glad to be done with it. Because, oh my gosh. Oh, that was stressful. Rotating loops. If the way I described that makes any sense, rotating the loop, because all you're doing is, anyway, unrolling a loop, putting it back together in the way that you want so that you can absorb some of the initial conditions or something like that. Anyway, thank you guys for watching. I hope you enjoyed this episode, and please don't ever write code like what I just did. That is a prime example of how trying to get the fastest execution out of code can lead to some other problems. If you've got all the memory in the world for your code, write the worst code you want. As long as it executes fast, sure. If that's really what you're optimizing for, you're still gonna make me cringe every time. Every time. And also, it builds on a lot of assumptions. Like, we couldn't possibly have execute... Like, if they changed even one parameter about that, it could have broken that loop pretty hard. So it's a very brittle code. Anyway, I will stop rambling about how bad that code was and say thank you for watching. I will see you next time, but until then, keep your gears turning.